about social and ethical issues in computing and what that means for you as a developer. We're going to look at understanding the issues, the rights and responsibilities of developers, how we can be sensitive to ergonomics and inclusivity, what software piracy means and copyright and how we can stay on the right side of the law there, the use of networks, software market as it applies to developers, and we'll just list out some legal cases that you might want to look at around this area. Okay, so let's start looking at the issues involved. So software has had a massive impact on our daily lives, absolutely huge, and in ways that we probably couldn't have really predicted. And our reliance on it has a massive effect on the consequences of it going wrong. So when we look at historical issues that have occurred in the past, Y2K, for example, was a huge issue where developers were relying on software being updated in the future before they would actually have to worry about using the full 4 digits of a date or a year. We didn't really understand what the full impact would be of that, but we spent trillions of dollars worldwide to try and prevent that problem from actually happening. It could have been very serious. It could have been very serious, but a lot of work was done to make sure that it wouldn't be. The impact of malware and what that means to people's safety online. How many people have lost their identities, lost money, been scammed, for example, or lost their files based around people being malicious on the internet. Online safety has become an increasing problem as well. I think a lot of people don't really realize just how traceable they are online. Cases of people being tracked down and stalked and even kidnapped based on the reflection of an address in the corner of their eye in a photo. Anything that you post online basically can be tracked to you. And anything that you do put online stays online forever. We know this. We've heard the horror stories. We understand how this works. And your digital footprint is extremely important to protect. If you like something on Facebook that's perhaps a little wrong, or if you express an opinion about something that might be considered inappropriate, if you post a picture of yourself behaving badly, these are things that will follow you around for the rest of your life. It is very important that you look after your digital reputation, the things that you're putting out there. People, when they are going for high-end jobs, when they're looking for scholarships, things like that, your online presence will be investigated. It is very important that you actually look after it. And this is part of our problem with relying on software. Every aspect of our daily lives depends on software working, whether it comes down to the toaster burning our bread, whether it's the car starting so we can get to work, traffic lights, sitting at your desk, the work that you do, everything is governed by software. If software doesn't work, it impacts every part of our life. We are completely and utterly reliant on it. And because we are reliant on it, we have to be very careful about the bias and the quality of the information that we consume through it. We've seen around the world just how people spreading propaganda has changed entire cultures, how it's influenced certain actions. If we look at Myanmar, for example, and how an entire ethnic group has been persecuted based around people posting stuff to Facebook. We can look at the recent division of the culture in America based around what's available online. American society is very divided at the moment. And a lot of that has been actually traced to foreign actors displaying propaganda and trying to convince people that the other side, whether you disagree with them or agree with them, whatever, that they are evil, that they are out to get you and change your way of life, real, imagined, or not. So it is very important that as developers, we understand that we have a certain responsibility and duty to consider these things when we're actually building software. Your online safety, as I mentioned before in the intro, is very, very important. We have become increasingly aware, or increasingly um, we've started using location-aware services a lot more recently with the release of the iPhone and then Android later on. Our location is constantly being advertised. And you have to sort of ask yourself, well, what trail am I leaving? If somebody was able to access that, how could they use it? Uh, Most people, when I ask them, have you ever been contacted online by somebody that you didn't want to be contacted by, has said yes. Why? Why have they been able to reach you? What have you done to allow them to actually access you? Is it worthwhile being more protective of yourself? And we're all very familiar with online bullying. And there are horrible stories about this. People whose lives are ruined by the way that people behave online because they believe they're anonymous. People are not really anonymous online. And there are consequences for these things. Bullying, as we know, is actually a crime. And if you bully somebody online, you can be charged with a crime for that. And it's very important that you actually are aware of this. And also, just don't be a horrible person, maybe. Probably not bully people. But if you are being bullied, you have to report it. You have to look after yourself. We've talked about the digital footprint, but I mean, it's very, very important that you actually are very aware that everything that you do put online stays there. Remember that there are companies out there that are creating a backup of the internet every single day and archiving it as much as possible. Nothing ever really gets deleted. You may think that you're deleting a photo on Facebook, but they don't actually do what's called a hard delete. They do a soft delete. That means that the file is still there, but all they do is remove the link to it on the service. The image can still be found. This image still exists in a lot of ways. So you need to be very mindful of this. Your financial safety and your identity online is also very important. I think we all are familiar with stories of people having their credit cards stolen or having their identity stolen and people taking out loans in their name. This is an incredibly important and emerging issue for us living online. People pretending to be you can ask family members for money, saying, I'm lost, or I'm stuck here, or I've had an accident. People are setting up entire businesses about scamming people online. It's very easy to create a website with a very similar URL and actually try to steal people's information. People do this all the time. You have to be very careful addressing these issues. When building software, we have rights and responsibilities as developers. And first of all, let's discuss our rights. We have intellectual property rights. This covers copyright, patent, and trademarks. Now, these three intellectual property rights or legislation are very different. Okay, so copyright is any artwork or any writing or any intellectual property that sort of exists that is not an invention or a business idea, falls under copyright. You cannot copyright an idea. If you have an idea and you tell somebody your idea and they actually then implement it, that's on you. Okay? You can't copyright things like a board game. Okay, you can copyright the digital art around it, you can copyright the rules, you can copyright the card text and things like that, but the actual mechanism of playing the game, that can't be copyrighted. What you could do, and for those of you who have ever come across Magic the Gathering, you can patent it. Okay, so patents protect inventions. If you invent a new way of compressing images, or if you invent a new business model, or if you invent a new game where you tap cards, as in Magic the Gathering, you can patent that. And that lasts usually around 25 years. A patent is designed to encourage innovation. So your invention can be protected for 20, 25 years, depends on where you are, whereby you can receive a return on your initial investment. After that period of time, that invention then becomes public domain. And this is essentially a way of saying, right, once you've created it, use it or lose it. Okay, trademarks are somewhat different. Trademarks are a way of protecting your brand. So for example, Cadbury have trademarks around that particular shade of purple that they use. Now, that doesn't mean they own that color. What it means is if you sell chocolate, you can't sell chocolate with that color. If you were selling a shirt, you could sell a shirt of that color. That's fine. If you were selling a car with that color, totally fine. But what you can't do is sell chocolate wrapped in that color. People often criticize Apple for suing everyone who has an Apple logo of some kind. They sued Woolworths, for example. The thing is, you have to protect your intellectual property rights. They knew they were going to lose that. But what they can then do the next time that they're suing somebody is say, look, we are being active about protecting our trademarks. This is things have happened in the past where people have not been protecting their copyright. They've not done things to protect their patents or their trademarks, and they've lost them and they've fallen into the public domain. Companies have lost entire operating systems because they didn't sue enough people who were making copies of it. Okay, so next time you hear about what you might think is a frivolous lawsuit, just think, is the company, is the person trying to actually develop a body of work saying we have been doing our best to protect our intellectual property rights. The thing that it's important to remember about copyright is that you get it immediately. So the moment you write a text that's original, or the moment you create a drawing, the moment you write a poem, you own the copyright. That you don't need to do anything to say that you have the copyright until somebody challenges it. Then you have to be able to prove that you own the copyright. That's where it gets tricky. Patents are registered with the Patent Office, and that's a whole different thing, as are trademarks with various government agencies. We have a lot more responsibilities as a developer. So when we develop software, we are obliged to consider these things for the quality of the product. It needs to be correct. In other words, if we're hired to build something, it kind of has to do that thing. It needs to be reliable. It needs to work. We need to limit the number of times that it collapses, that it falls apart, that it breaks, that it stumbles, that it does all of its things. It needs to be efficient. That means that when we are using it, it needs to operate in a reasonable amount of time. It needs to be able to do things in a reasonable manner, not hog all the resources of the machine that it's running on. It needs to be flexible. Not everyone does work in the same way. Okay, so when we use software, we often do it in a very different way to the person sitting next to us. If you think about how people set up their computer, they're very different. If you were to try to use somebody else's phone, you'd probably be completely lost. We all use software in a different way. We can't tell whether something is correct unless it's testable. So we must build software that we can actually test. If we can't test it, we don't know whether it actually works or not. Portability refers to the software allowing us to transfer information that's created in it into another platform or another application. So we need to be able to say, right, I've created my document in this particular package. I need to be able to take my data and then edit it in something else. So the application doesn't control the data that's generated by it. You may be surprised to hear that you can actually download all of your data from Facebook. You can download all of your data from Google. They allow you to transfer your data from their platform to something else. It needs to be reusable. We don't want to create software that is used once. And interoperability means that your application will not stop all other applications from working. So if you have a browser, you need to be able to have your email open as well, a spreadsheet open as well, any other application. Okay, it needs to play well with others. Maintainability means that it can be worked upon. When we build software, it's probably not going to be the final version of it. So it needs to be built in such a way that other people can come after us and actually maintain it. Integrity means that the data is correct. So we would hate to put something into a system, have it corrupt the data. That would be very, very bad. When it comes to creating quality software, however, there are often external factors that will impact on this. A lot of things that we have no control over. So once you deploy software, the hardware that it's running on is largely out of your control. As long as you can say, well, look, it's running on Windows, it's running for Mac, okay, that's fine, but what Windows machine and what Mac machine, what's going on with the hardware there? You will probably not have much say over it. And if you do require to have a certain amount of hard drive space or a certain amount of RAM or whatever, and it's not provided, it's probably not going to work as well. It's not really your fault. The operating system that they're going to try to run it on, third-party software may not actually be built as well as your software. It may not be interoperable. It may create problems for you. Runtime errors occur all the time, and this may be the user doing something that you're completely unfamiliar with or were not expecting. That's not necessarily your fault. And the thing that we definitely cannot control at all, ever, the capabilities of the user. Who knows, they might be an idiot. So, we've encountered problems with our software. Problems are inevitable. Nobody builds good software yet. We are still in the dark ages when it comes to software development. You will not find all errors. You may be the best test person ever out there. You will not find everything. There is always one user who's going to find a way to break your software. It happens. Having said that, not all errors are serious. So it is important to understand that you do not have to treat every single error that occurs in your software as being earth-shatteringly important, because the majority of the time it won't be. Sometimes it's just don't click that button again, or make sure you find the right file, or try to limit it to X, Y, and Z. When you are presented with a problem with your software, it's important to classify its severity. If it's critical, you should probably get to it straight away. If that's probably a security problem or something that's corrupting data or something like that, you probably need to get to that immediately. If it's major, you probably want to have something within the week. Maybe a month, but probably a week. If it's a normal error, you could probably wait a while. You could probably wait a long time. If it's cosmetic, well, you might wait until the next version of the software is released, because that's just how it looks. Okay, so that's not necessarily a problem at all. Okay, so we've talked about our responsibilities and we've talked about response times and everything else. There exist codes of conduct for developers out there, and we're going to look at a couple of them, and you might want to be sort of thinking about whether you think these are a good idea or not. So, organizations have been established to build trust within industries, and this goes all the way back to the medieval trade guilds. Okay, so if you were to go down into London and you wanted to buy a pair of shoes, you'd go to somebody who was a member of the guild of the shoemakers, because you knew that they had to actually pass an apprenticeship, create their masterpiece to be allowed to be called a master, so they could actually do whatever they did. Okay, so this allowed you to have trust that you were buying a good, high-quality pair of shoes, if that's important to you. IT and engineering organizations exist in the same way to create a sense of reputation and expected behaviors from your peers and everything else. The IEEE is probably the most prominent in the software world. It's an engineering organization. It is French. And they govern so many standards, things like Wi-Fi, JavaScript, Ethernet, C++, all the rest of it. They have a long list of things that they actually govern. That means that they're largely in charge of how these things are developed, worked on, and everything else. They have a code of practice for its member engineers. So if you join the IEEE, you are bound by these 10 rules. We'll go through them quickly here. So the first, you have to accept responsibility in making decisions consistent with the safety, health, and welfare of the public. You can't be a supervillain, essentially. You also have to disclose promptly factors that might endanger the public or the environment, i.e. don't take any shortcuts with people's lives. You need to avoid real or perceived conflicts of interest whenever possible. So basically, don't do jobs for your cousin and charge them too much money, and blah, blah, blah. You need to be honest and realistic in setting claims or estimates based on available data, i.e. don't over budget or overprice things. You need to reject bribery in all its forms. That tends to get people a little bit sort of, that makes them uncomfortable. If a development company gives you an umbrella, or they give you pens, or they give you, swag, is that a form of bribery? If they buy you tickets to a game, or they buy you tickets to a concert, is that a form of bribery? They are sort of pitching for a contract. Could it be? Yeah, it kind of could be. You need to improve the understanding of technology, its appropriate application, and potential consequences. Okay, improve the understanding of technology, that right there is fix your parents' router or fix your parents' printer. Maintain and improve our technical competence. i.e. keep on training and don't limit yourself to just what you know now, keep on improving. To seek, accept, and offer honest criticism of technical work. Basically, have I done this right? What could I do better? You've not done that right, etc., etc. Also, credit properly and the contributions of others. That's kind of important. To treat fairly all persons, regardless of such factors as race, religion, gender, disability, age, or national origin. I'd hope we'd be doing that anyway. To avoid injuring others, their property, reputation, or employment by false or malicious action. And to assist colleagues and co-workers in their professional development and support them in following this code of ethics, i.e. dob them in. There are also other governing bodies. We have one here in Australia, the Australian Computer Society. There's a British Computer Society. Their codes of conduct are way longer than that and go into fine minutiae. Look them up and read them. They're interesting. They don't really... Well, we'll come to this in a second. So, what do you think? Do you think it's something that's good or something that can kind of largely be ignored? Well, let's have a look. So, codes of ethics pros. Reputation, expectation, and if you're doing any kind of work for the government or for the military or things like that, you actually may be required to be a member of a code of ethics society. The cons are it's actually costly. It can actually limit what you can do. Obviously, don't break the law, but you wouldn't necessarily be able to get away with everything. And this is the kicker. There's absolutely zero repercussions for not following the code of ethics. And it's one of those interesting things. In the syllabus for NESA, they really bang on about the code of ethics and how important it is. You go out into industry, they really don't care at all. And even when I was studying for my master's in IT at Sydney University, our lecturer who talked about this said, yeah, don't worry about it. It's never going to be a thing. And he had been at IBM for decades. So, you may want to reconsider whether it's something that you care about or not. But you do need to know it for the course. Okay, let's talk about ergonomics and inclusivity. Okay, so ergonomics are the study of the interaction of humans and their environment. So in other words, how do people interact with their computers in this case? So largely through user interfaces. Okay, so how do we create a good user interface? This is an entire career or topic on itself. You can actually go to university and study user experience and user interfaces as an entire 4-year bachelor program. It is a kind of a big deal. And it's becoming increasingly important and increasingly necessary to understand this. We, however, are only going to look at very tip of the iceberg here. Okay, so essentially, set design standards in your program and stick to them. If you have an icon in a particular place, don't move it around. If you have a certain color palette, stick to it. You need to then take those set of rules and apply it to the entire application. If you decide to mix and match, you can confuse people. People are going to get annoyed. It's going to be harder for them to use your software. Use the correct controls on forms. What do we mean by that? Well, in the software design context, controls are a way of controlling the data in the interface. So that means use buttons where you need buttons, use labels where you need labels, use text boxes where you need text boxes, etc., etc. Don't use things like check boxes when a radio button would actually be a much better choice. It's important that we use colors appropriately. That means no fuchsia backgrounds with a lime green text. That's very bad and evil. Fonts are particularly important. When we are designing interfaces for an online experience or for software, we try to use sans serif. Serif fonts can blur and make it harder to read. This is slightly mitigated by the high resolution of our screens currently. However, it is worth remembering that the majority of interfaces are probably best served by sans serif font. My pet peeve is aligning controls and elements properly. When you see labels and text boxes all over the screen and none of them line up properly, it drives me nuts. Make sure you're lining them up. Make things the same width. Put buttons in the right spot, not just randomly over there in the corner. Perhaps more importantly, and this is probably the most important really, is prove a consistent way to undo actions. Software needs to be forgivable. In other words, it needs to allow a user to be able to undo actions that might ruin their data. So provide a consistent way to undo that. And most importantly, you need to test your usability. You are too close to the software that you develop. It's really important that you give it to other people to try and use and watch them use it and see, oh dear, have I done something wrong? You've been working with it, you're too close to it, it's much better to get somebody else to test it out. If you're interested in this thing, human interface guidelines exist. They're actually a pretty interesting read. All major software and hardware companies have them. They're called Human Interface Guidelines, or HIGs. They exist from Microsoft, Apple, Adobe, Google. They all have them. If you're building any kind of software for a Windows environment or an Apple environment or whatever it happens to be, you'll find it's actually fascinating stuff. I just read the Adobe one recently, and it is very enlightening in terms of how to design like a good interface for people to interact with. When we're talking about inclusivity, it doesn't serve us to design software that deliberately makes it hard for people to use it or to needlessly offend people. So when we're building software, we need to remember that everyone comes from a different cultural background. Some things may be hugely offensive. And while we don't necessarily need to pander to everyone, if we don't want to needlessly offend them. In other words, if we can avoid it, let's avoid it. There's no point in creating something, sticking to your guns and going, no, it's your fault, you're offended, if we don't have to offend anyone. Sometimes you may need to, but you don't want to if you don't have to. Naming conventions can be different. They can vary widely around the world. When Google released Google+, they didn't take into consideration that people might have surname first and first name second, or might only have a single name. There are plenty of people out there who legally are only identifiable by one name, and Google could not deal with it. The way that numbers, currency, and dates are displayed are different around the world massively, and if you want to make your software understandable in other places, you need to be able to adjust for that. Now, the operating system may do a lot of the hard work for you, but you need to enable that within your software. Where possible, provide language support. There are translation services out there. It's actually fairly easy to create language support in your software, and it's not that as expensive as you might think. Try to be sensitive to religious beliefs and cultural traditions where possible. Obviously be mindful of gender issues and economic background, which a lot of people actually tend to forget about. And the most important of all of these is provide a way for people who have different abilities to interact with your software, whether they need a screen reader, whether they need somebody to read it out to them, whether you've got sound in your applications that's important, they might be hard of hearing, or if they need to use different devices to enter or to manipulate their computer, if they need a pointer or something else. There are really easy ways to make sure that your application is accessible to people that might need a different way of interacting with your product. All right, let's talk about some privacy issues. So privacy issues are an increasingly important and relevant issue with the explosion of social networks, location-aware applications, smartphones, all the rest of it. Your privacy has become a product that is sold online. So your personal information is a commodity. It is used for marketing. It is used to selling ads to go against your eyeballs and sell you things. General rule of thumb, if software is free, you are the product. Facebook makes billions of dollars from selling ads against your information that you happily provide for it. TikTok, ads. Reddit, ads. Twitter, ads. They gather as much information about you as they can. Why does Google provide a free operating system for Android devices? To know where you are. Remember, 95% of Google's revenue comes from ads. You are the product for Google. Your search history, where you go, what you look at, where you are. A lot of apps listen to your microphone and try to gather what you might be wanting to be interested in based on your conversations. Okay, think about it. Your privacy is frequently being intruded upon by applications that want to sell your information to other companies. Whether you care about that or not, it's important to be mindful of it. In 1988, the government created the National Privacy Act, and this has become quite important, particularly recently where, and I'm going to date this video immediately, the Optus data breach, which is extremely serious. This act is basically set out to try and protect the data that is kept by companies about you. So any business that wants your information must explain why they want your information. They must provide access to what they've collected about you when you ask for it. So you can go to your telco and go, give me all the information you have on me, and they have to provide it. If there's anything that's inaccurate, they are required to correct that as quickly as possible. Obviously, that's not a precise term, but if they take a month to change something, they'll probably get in trouble. They need to let you know who they share your information with. They need to describe why they need your information and describe how the information is stored and how it is managed. All of this is usually in the fine print, 4-point text at the bottom of a contract that you never read. Next time you see it, I encourage you to read it and have a look through. Because they'll tell you, we sell your information to this marketing company and this marketing company, we sell it to this and that and the other, we sell your information here, blah, 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 blah. It's important to be aware that whatever you provide to a company may actually be passed on, and just be mindful of that. All right, so let's talk about piracy and copyright. So, in the digital age, piracy is a serious issue. Before the internet, if you wanted to make a copy of something, you had to photocopy it, or you had to take a picture of it, or you had to handwrite a copy of it. These are all things that were, a lot harder to do. If you wanted to make a copy of an album, you had to do it in real time. So if you had an album that was an hour long, it would take you an hour to make a copy of it. Now, for example, if you want to share a movie, you can share it 1,000 times in seconds if you have the right kind of connection. So piracy in the digital age is exponentially worse than it has ever been in the past. In particular, the music and movie industries have made claims that it's seriously impacting the industry, yet they keep on posting record profits. So it's hard to know if that's actually real. I'm not advocating, obviously, for piracy, but I don't know if it's been as big an issue as they would claim. So in an online world, issues around copyright and piracy are a lot more complex, and it's important for you to understand your rights and responsibilities in this regard. Okay, plagiarism, just reference everything. Using somebody else's intellectual property and claiming it as your own, even if you had the right to use it, is plagiarism. Just make sure you reference everything and just get that out there. Okay, so copyright laws designed to defend, safeguard the rights of intellectual property. Why? If you're an artist, you make paintings, that's your way of living. If somebody starts selling copies of that affects your living standards, that's an issue. They were first introduced at the start of the 20th century. There was actually quite a lot of resistance to it. So it's kind of interesting that they've become so important now. It was updated in Australia in 1968 and again in 2006 as part of our trade deals with the United States. And the copyright has been just extended and extended and extended. So it's kind of annoying. But having said that, it does allow for artists and companies and authors and all the rest of it to make a living from their work. You need to check, though, because in Australia, you may be able to make copies for personal use and backups. So it's important that you sort of remember that. We're also allowed to digital shift. So if we buy a DVD, we're legally allowed to make a copy of it in Australia to play online. Not share, but just have a different version or a different way of watching it. If you do then sell the DVD, you're obligated to delete that copy that you've made, the digital version. Okay, so if you are the owner of copyright, you have the right to reproduce the copyrighted work. You have the right to make derivatives of the works, to distribute it, to perform it, to display it in public, and all the rest of it. Those are your rights if you own copyright. Limitations: if you buy something, you can only make one copy to back up. When ownership is transferred, all other copies you've made must be destroyed or handed over. Here, and this is increasingly difficult to sort of it's murky. Decompilation and reverse engineering are prohibited with some special caveats. Some people have some different ideas about this. But if you compile software, you have a reasonable expectation that somebody won't decompile it or try to work out how you've done it through reverse engineering and then sell it on to somebody else. Okay, so the caveats have been people who've created ways of limiting using hardware, for example. Sega and Atari, for example, were the ones that were hit with this, that where they had ways of making sure only their software worked on their machines. People found a workaround. The court said it was legal. So just bear that in mind. 4 common classifications, and this is people often get this kind of mixed up, so it's really important you pay attention to this. So here are 4 common classifications of copyright, or licenses, should I say. Commercial. This is a standard. You buy it, you get to use it. Okay, it's a commercial license. You pay money, you get the right to use it within a certain context. Open source doesn't mean that it doesn't have copyright. It just means that you have the right to read through the code. Sometimes this is important if you are wanting to use a particular cryptographic system or a particular encryption or something like that, but it doesn't necessarily mean that it's free. Now, having said that, it nearly always means that it's free. Okay, there are only a few companies that have open sourced their products without actually saying, oh, it's actually free for people to use. And in fact, open source, pretty much everyone's expectation is that it's free. It's often quite a surprise for people to learn that it doesn't have to be. Shareware and freeware are things that used to be important, but really aren't anymore. In the old days, before good internet, you'd buy a PC magazine, it'd have a CD on it, and on that would be trial software, essentially. That would be shareware. So you could use a limited version of it. It would work for a limited amount of time. It would have a limited feature set. And then that you could buy to, buy the full program to actually use it properly or whatever. Or freeware, which is just utilities that the developer has not sought to try to monetize in any way, or they just want to provide it free for people to use. But they still want to maintain the copyright for it. Okay, so it is important to remember that shareware and freeware, the person who created it still maintains the copyright of it. Public domain means that it's a free-for-all. It's out in the public, nobody owns the copyright, anyone can use it. You could still be accused of plagiarism, however, if you use it. Okay, so just remember that if you get public domain source code and you pass it off as your own, you could still, if it mattered, be done for plagiarism. Okay, so that's important. Now, there have been many, many attempts at combating piracy, and most of them have never worked. In the old days, the old dark days, you'd have a non-copyable data sheet. So it would have codes that it could ask for, and that sheet could not be photocopied. You could make a handwritten list that could be copied on the photocopier, though. So that didn't really work. People would put disk copy protection on software. That never lasted. Hardware serial numbers. So it would have a look at your hardware and go, okay, that's going to be your serial number. That didn't work either. The only things that really have worked, registration codes, that's nothing. Encryption key, that's nothing. A site license installation counter on a network, that, again, doesn't necessarily work. The only thing that has seemed to work is a back-to-base authentication. In other words, your login details are encrypted in the software. It then talks to the server back somewhere else and confirms that you have the right to it. That's about the only thing that has really worked. That and Steam being very popular, people not wanting to hack Steam. Steam has largely done the right thing by both developers and players, and so it's not really led to a lot of people trying to pirate it in such a huge way. It's not on the list, but it's important to sort of remember. All right, use of networks. This is a little bit of an odd part of the topic. Networks are good. You can use network software. Loading speeds are important. Bear that in mind. Client-server model is going to become increasingly important. Moving on. Okay, let's look at the software market, because that's going to apply to people who actually enter the software market. All right, things to consider. When you're building or designing or developing software, this is a good question for you, a good series of questions for you to bear in mind. What is it that you intend to sell? Where will you sell it? Okay, these days you would nearly always sell it online, but you might still sell it in shop fronts, although I don't ever recall seeing anything to buy in a store of software related in a very long time. Or it might be industry specific. For example, if you are designing software to manage factory systems or things like that, that may be a very specific thing. What do you sell it for? So cost, profit, consumer-based pricing, these are all things that you need to bear in mind. It's going to cost you a lot of money to develop something. So how are you going to make money from it? How are you going to promote your product? Marketing is important. How are you going to be competitive? And how can you be disruptive? If you think about all the big software out there, what the thing that's made it successful is disrupted the market. It has changed the expectations of people who use it. If you think, you won't be able to think back, but imagine the days before the iPhone and Android devices, where every phone had a keypad, where every screen was small, tiny, black and white, monochrome, where there was no applications for it, there was no internet browsing and all the rest of it. And then all of a sudden, boom, iPhone is announced. It was disruptive. Was it innovative? Yeah. Was it original? Not necessarily. Phones had existed for a long, long time. Mobile phones, everyone had a mobile phone at that point. But it was a disruptive product. It was a complete reimagining of it. Okay, so can you be disruptive? That's the way to make yourself truly successful. We're obligated to look at legal cases as well. Here's a list here. I won't go through them too much, but these are pretty massive cases that have revolved around social and ethical issues. Apple versus Microsoft is kind of an interesting one. Microsoft was actually hired to build software for Apple, or Bill Gates essentially, back in the days before Microsoft was really a thing. And the contract that he got Steve Jobs to sign basically gave Microsoft the legal right to create Windows. Prior to that, a Windows-based operating system was owned by Apple. You can imagine a world where only Apple ever existed and there was no competition. They basically signed a perpetual license. Steve Jobs was furious, but to his credit, when Apple needed the money, Microsoft gave them $400 million loan to basically get back on their feet. So it's not entirely bad. And towards the end of Steve Jobs' life, Bill Gates and Steve Jobs would talk about their fondness for each other. It's very interesting how they've gone in different directions, but we'll talk about that more in person.